Basically, as Tanguy mentioned previously, I was responsible for defining bandwidth on demand service in GN3 project. So now I would like to provide you some ideas about how we can extend the reach of, extend the scope of bandwidth on demand service and work together with other activities to provide this set of services to our end users. So basically, I will share with you my vision where end users typically are located and how we can reach them. Then I will tell you about MDVPN service and share with you my ideas about practical solution for campus networks. So basically, today during this workshop, a few times were mentioned that we have BOD users, but in most cases there were big players, so big projects with huge requirements for bandwidth, like VLBI, for instance, or LHC1. So the big projects generating a lot of amount of data, and these are well-known projects connected to Jean infrastructure or national NREN's infrastructure and using BOD. But it's relatively small number of such projects. We have also, depending on structure of NREN, metropolitan networks where universities are connected, and some users are connected as well directly to metro networks. Usually there are middle-sized users, some research groups, labs, and stuff like this. However, we also have campus networks where small labs are located, individual research teams are sitting, and I'm expecting that this is pretty large number of users, potential users, because we have labs for even for students, small labs where measurement equipment is located, small clusters are placed, sometimes conferences are organized. So I think the most of small users are located in campus networks, and one of our goals should be reach those users. And in case of metro networks and NRENs, usually if we have resources in our network like interfaces and there are no financial limitation, it's quite easy to reach these big players because they have also a quite good infrastructure, and we can reach them in easy way. In campus networks, the situation is a bit different because they are much more closed. So we have to we are facing trust or security issues. So if we want to provide some software for those administrators, we have to convince them the software is secure and safe for them. Usually there are individual security policies implemented in each campus network, and they differ between each other. So we have to deal with these problems. So one of the idea which can be implemented to reach the end users is to tunnel the BOD traffic through the campus network. So basically we have to, I would say, provision simple VLAN in campus network, because mostly from my experience is that the campus network are built as layer 2 switch networks using Ethernet devices. So we have to provision kind of simple VLAN in campus network and put our BOD traffic into that VLAN. So how we can do this? Basically, we can use available multiplexing techniques like, for instance, stacked VLAN IDs. It's common known as Q in Q or PBB PBT. But this techniques has, as Jerry mentioned, has quite poor scalability because of Mac learning process. So that's something which can be easily implemented by campus network administrator, but it's not scalable solution. We can also use MPLS labels, which has far more better scalability than VLAN stacking. So,
how often do you find MPLS capable equipment and staff on campuses?
This is something I think it's. Yeah.
So, how often do you find MPLS capable equipment and staff on university campuses?
This is. I will maybe answer your question later, because there's one of the. Oh, the thing is one of the. Yeah.
Sorry. I'll argue for you.
My idea, I will show you on the next slide, is to use simple boxes, simple MPLS boxes, which can provide access to. Yeah.
Someone is checking in an airport somewhere. Oh, he's off.
Okay, so let's continue. So basically, my idea is to use transparent tunneling technology, which will not interfere with campus network infrastructure. So in order to put BOD traffic in the tunnel, we have to install small CE box as close to the end user as possible. And then, thanks to abstracting the topology, we can add port on this CE box as an access interface to BOD infrastructure.
And who's managing this box? You are the
I think it depends on who will manage the box. I mean, it depends on agreement with campus network. If we agree that, I mean, if the box will be delivered by, for instance, Metro Network or NREN, then probably it will be managed by NREN or Metro Network. But it can be also provided by campus network administrators, but as separate box used for BOD purposes only. Yeah? So it will not interfere with other part of infrastructure in the campus network.
This is also consistent. This is also consistent with some of the what was it? The YesNet's doing?
Science
Yeah, the Science DMZ stuff, where they're putting
Yeah.
a box off to the
Yeah.
side
Yeah.
and using that to shunt the traffic
Yeah,
away.
yeah,
Right.
yeah.
So this is actually a technique that's starting to gain acceptance for certainly the high performance flows.
Yeah.
For the high performance flows, how are you going to guarantee quality of service?
I mean, this is also if I mean the main problem is in the campus network. So basically, you also have. It's not the question of putting anywhere the CE box. You have to agree that with network admins. Yeah? The bandwidth guarantees will be provided by campus network administrator by for instance, over provisioning the network or delivering direct links, depending on possibilities in campus network. You know, so that's something you have to keep in mind, that it's something. If you implementing something in the network, yeah, you have to agree with administrator how you will reach your goals. Yeah?
And just one question, and the MPLS demarcation is at the NREN side?
It depends. It depends on how you configure that. Maybe I will go to the next slide in order to show you how we can use existing resources. For instance, MDVPN service. Short introduction to MDVPN service. It's in general, it's baseline infrastructure for providing multi-domain transport services. So thanks to using well-known protocols like BGP, RSVP, and extension to that protocols, you are able to provide seamless transport services over many countries in Europe. So as you can see on this picture, a lot of NRENs are connected to the testbed or actively participating in deployment of this MDVPN service. So you can create point-to-point and point-to-multipoint topologies, transport topologies. MDVPN supports Layer 2 VPNs and L3 VPN services, and it's operating in multi-domain environments. So basically, you can see many NRENs are involved already in building the service. Thanks to MPLS technology and BGP protocol, it provides almost perfect scalability. It's ready to support, thousands of VPN services without negative impact on transit domain. Yeah? So that's very good scalability of this service, and BOD can use this MDVPN infrastructure as a transport service. So basically, MDVPN does not provide automatic provisioning. So it's more like transport infrastructure. It's not a service provisioning functionality. Yeah? So BOD provides already user interface, like for instance Autobahn and other applications, Oscars and stuff like this, provide end user interface to implement the service in the network. So you can combine those two technologies together in order to provide complete transport service for end user. So thanks to this abstracting of network topology, you can virtualize the MDVPN infrastructure in the way how you want to, how it is appropriate for you. So in very basic case, you can use MDVPN as virtual switch. So you can create model of virtual switch and. Yeah.
So let me get this clear. You're saying we set up the VPNs, and then that would be the topology over which the BOD would allocate its resources.
It is one of the options available. Yeah. So you can use part of this infrastructure and create abstract of this topology and use it as virtual switch for BOD. Huh?
But you can also prolonge, I don't know the word, like prolongate or extend.
Extend, I mean, that will go in the next slide, because as you can see, MDVPN is based on MPLS technology. So now Jean and Pioneer Network also are using MPLS technology to implement BOD service. So Jean are using Layer 2 circuits on Juniper MX platform. Right now, Pioneer is using a Foundry XMR platform. It's
so we can serve the Polish users.
Yeah. So the thing is, both technologies are interoperable. So they are using MPLS transport and MPLS-based services in order to implement BOD point-to-point links. Yeah? So going back to the campus networks. You can install a small CE box, PE, because it depends on which site you're looking at the box. And you can use the small box to reach the smaller teams of researchers. Even because of size of this box, you can put this box almost on the desk of the researcher and say, okay, on a particular interface, you can reach some services. Yeah? And one of the idea which stays behind of using the small boxes is to invite somehow end users to start using our services. Some idea, similar idea like telco companies are doing. Yeah? You're getting, for instance, phone with a camera, and they are hoping that you will send photos over the network. Yeah? So thanks to relatively small size and small cost, of course, of such box, you can install in many places, I call it demo packs, and provide access to the services for end users. And because I believe what is important for the bandwidth on demand and other services is to exceed some critical mass of users. We have to. I mean, that will be like services like Facebook, where people are talking to each other about some events and stuff like this, and thanks to exchanging information, they are starting to do something similar. Yeah, and we want to get the same goal. Yeah, so start to talk with people and invite them to use services.
My only comment, it says this is basically a twist on the notion of using Ethernet over MPLS, for instance, for these circuits, which I think has a lot of credibility to it. The one question I have kind of goes back to user support. It seems to me that this forces the campuses to turn on things like GMPLS, RSVP, or CLLDP, something to do to label distribution and do the MPLS setup, right? Which we should be careful about, because that does make the campus network.
No, the thing is,
I mean, I think it's a good technology. I think it's scalable. It's a good.
Jerry, but note on this slide, if you look at this, I mean, this part doesn't have to implement MPLS, because if you will put the CE box here and create VLAN over that network, so the MPLS signaling will be only running between NREN network and this.
So you're saying you're going to bypass all the routers in the campus?
Yes, that's the basic idea, because we don't want to push campus network admins to change the network. Yeah.
If you do it like this, if you say you have a CE somewhere there and then your box somewhere outside the campus, and in between the CE or PE in this case, and your box is no MPLS, that means you have some other sort of tunneling.
No, I mean this box. I mean in my.
You do a VLAN.
I mean no. In this case, if you look at this box, this small Juniper SRX firewall can support MPLS-based services. So that's the. I mean, I gave this example because. €1,000 now. I mean, it's we had 10 boxes for $120 for one piece. So that's relatively small cost, but it can deliver pure MPLS-based services. And additionally, in future it should support LDP downstream on demand. So the provisioning of preparing the configuration for that box and MPLS operation will be simplified to the minimum. So that's something you can easily implement. But I'm thinking about this as demo pack, because I think if we will reach the end user and he will know what the service is and he will find the way how the service can be used by them, then probably he can go back to us and say, okay, that service is fine, but I have some additional requirement. So we have adjust our implementation to the specific needs of this user.
So just a couple of questions. So one in between that box basically and let's say the NRN connection. So basically, you're having a kind of an S-tag VLAN which is propagated through the campus.
No,
and inside
because here this box is using MPLS. So basically, what we need single VLAN, because the multiplexing is based on labels, not on.
Okay, I see. Okay. Yeah, no, it's okay. No, just.
It's not okay because I'm not running with the microphone all the places.
And
questions.
Yeah, just another thing. And the other question is, in MDVPN, basically, there will be a single IDM basically controlling the whole federated group of NRENs, because you will have to set up only the two PEs in two different NRENs.
I mean, that's possible, but it depends on the goal you want to achieve. Yeah, if you want, for instance, I have this picture. For instance, if look at the Pioneer example, we have National Research Network, which connects some metro networks together, and to the metro network are connected campus networks. Yeah. So basically, what we can do, we can of course create single domain connecting all MPLS boxes in single BOD domain, but we can also create smaller metro level BOD domains and map the campus networks to that domain. So it depends on the many conditions. I mean, you can adjust this abstract topology to your needs. Yeah.
But you are actually using that or planning to use that in Pioneer already.
Yes, I mean that's my idea to reach end users located somewhere in Poland, in campus network in Poland. However, I mean it's looking at the scope of MDVPN service. This can be easily replicated in the metro networks and national research networks implementing MDVPN.
But can you do that independently of the multi-domain VPN, just on campus? Just
I mean,
between,
yes,
so
of course.
just between like the NRAN POP
Just imagine
and the end user on campus.
Yeah, just imagine campus network in metro network with few campus network connected together, and metro network has access to NRAN. Yeah, so basically what you can do is to create abstract of the metro network in BOD, and this will create a virtual switch with end interfaces located in the campus network, and the other side it can be interfaces connecting the metro networks to the NRAN. Yeah, so that will create a virtual switch in BOD world, I would say. Yeah?
Yeah, the questions that come to mind here are, if I get real nervous whenever somebody says, they're going to do the multi-domain stuff for my domain. That starts ceding authority, and I don't think most networks are really going to let that happen. Particularly if you're talking about dedicated, big pipes, right? I think yes, they may be able to signal it through, but then that begs the question of what's the policy that's being implemented? Where is it being enforced?
I mean, you're talking about MDVPN right now, or you're talking about
across the campus network, right? If somebody in the UK wants to set up a circuit across your campus in Poznan, right? Are they going to be free to do that? Where's the policy decision being made?
I mean, but that's the general question. I mean, in upper layer, because we are talking about implementing a BOD on top of that. Yeah. So if we don't have in BOD service these policies, so we are stuck anyway. You know?
Right, but our model has an NSI compatible agent, right?
Yeah.
That covers a domain, right?
Yeah.
What they do inside that domain, we don't care.
Yeah.
Right? But there's a very definite edge.
But it's just
yes, that will be
just
the
an
edges.
extra.
I mean,
Okay.
but you can adjust the edges on your goals. Yeah. If you want to say, okay, my metro network plus campus network, it is single domain. Yeah. You're just abstracting this. If you
networks agree to it, then that's fine.
Yeah. But I mean, I want to say that the MDVPN provides flexible transport infrastructure, so you can easily implement. I mean, you can abstract this MDVPN structure as you want, yeah, as you need.
So as far as I understood MDVPN, it is so that you don't start to exchange labels within the domains. You have, so is my interpretation of it. You still have, say, fixed demarcation points, and the labels between, say, the GANT backbone and an NRAN doesn't get exchanged. So if I use the GANT backbone as an perhaps the Cisco term is bringing it a bit closer. It's carrier supporting carrier. You know that?
Yes.
So what we were proposing and what we've done with some of our NSI experiments, we've used NSI, and then when it signals across our network, it does a circuit cross connect of an Ethernet frame into an LSP. Signals that LSP across, and then pops it out the other side.
Yeah, but what you do is you stick another label on the each domain has its own labels. Yeah, and they don't exchange labels. And if you want to say, if you are a provider who has,
You don't need to exchange.
you don't have to exchange it.
Because they're just like local, right?
Yeah.
So if there's a couple of things that I was trying to ask you earlier. If you're talking about putting up the VPN across the domain and then using that as the allocated resource upon which BOD places its circuits,
Yeah.
right? So you have two layers. You have the IP layer, right,
Yeah.
with the MPLS routers and what
Yeah,
have you,
yeah.
right? And then you can set up a VPN across that,
Yeah.
right? An MPLS LSP,
Yeah.
right? Right. Now you have, say, 5 gigabits
Mhm.
across there that's allocated to that VPN.
Yeah.
You've got equipment at either end of that, right?
Mhm.
You don't care about anything in the middle. It's just a tunnel.
Yeah.
Now you can use BOD to allocate that capacity as necessary for these end users.
I mean,
I mean, there's a number of different ways. I think the bottom line here is that the MPLS
Mhm.
is a really scalable technology. We should
Mhm.
really explore that.
Yeah, yeah,
And how VPNs would be one way of employing that.
Yeah,
Right?
yeah.
The Ethernet over MPLS would be another way.
Yeah.
There's this notion of building stack LSPs where you have your infrastructure.
Yeah.
But you build an artificial network topology
I mean,
on
you're
top
just
of that
virtualizing, yeah.
for your circuits,
Yeah,
right?
yeah.
Which is now LSPs on top of LSPs.
No. The thing is, you're using LSP to deliver just data, yeah? And you're using BOD service in order to provision service on top of that. Yeah? And
No, I'm using LSPs to deliver Ethernet frames.
Yeah. yeah, so this is BOD. I mean, this is BOD implementation in Pioneer. You're using MPLS in order to transport Ethernet frames.
Right.
But the service instance created for that is provisioned by Autobahn. Yeah?
Okay, sorry, Jerry.
No. I think one of the, I mean, a very interesting discussion about, you know, how to layer stuff on top of each other. But I think also the important point here is to see how we can breach that last mile and see if this is a approach we can take right now, if it's something we should pursue. Because I mean, that's the problem Tanguy has all the time. He goes out and talks with the user.
To me, that MPLS is becoming more prevalent, even in these campus networks. I mean, they may not turn it on, but they have the equipment.
Oh, it depends, Jerry. I mean, it depends on local conditions and the campus network I know in Poznań, for instance, they are based on pure layer 2 boxes with some routing functionality, but they are not looking at the MPLS anyway. So the thing is, we have end users located in campus network, and we have metro network which can probably easily install BOD systems. Yeah. So what we can do is we can jump over the campus network to reach our user. Yeah, with single VLAN. I mean, with the simplest way. I mean, the thing is not to disturb operation of campus network. Yeah, because if you will go to campus network admin and say, I want to modify whole your network, then he will thank you and the game will over. Yeah? But the thing is, you have to reach this user with not so.
Tomek gave the scope of what this is about, or at least where we could start at the beginning of his presentation by saying we know the big players with resources. What do we do in the most lightweight possible solution where we have like a demo pack with something that costs $120, not so much manpower, it's not intrusive, and we just do that even if some of the properties, in terms of bandwidth. I would be very interested, and I need to stop you there, but we'll continue after. But I would be very interested in I'm interested. I'm in the IT service of a university, and I'd like to pilot that. And for example, if We have some users on my campus who are interested in getting to some endpoints in Germany where there's no bandwidth on demand yet. So if you're interested, we could try and pilot things with a very limited budget. Try and do things, and if anyone else is interested, just try, and we can actually serve a few use cases already. That would be great instead of just demoing. We can get back to that, but we just need to go to the end of the presentation first.
I'm gonna leave.
Maybe I will answer the Jer's question, because I mean it's quite interesting. So
Well, yes.
yeah, I mean, so basically, going back to this small box, it can be managed by I mean, natural way will be if it will be managed by metro network operator or even NREN, depending on the organization of NREN. However, the operation performed by this box are very simple, and the configuration of that box is also very simple. So basically, these are 100 megs interfaces. So we're not talking about delivering high bandwidth circuits, but what we want to do is to show the features of that service, yeah, and to say, I mean, to the end user. To show him how he can use some available tools. Yeah. So that's the main idea of this demo packs, to present and to allow them to experiment with that.
Well, I would just say the demo pack, whatever you do, should be able to make sure that you can enforce whatever performance, whatever your performance specifications were in the core.
Yeah.
Should be able to extend out to wherever your demo pack is.
Mm-hmm.
So, yeah, maybe it can only do 100 meg, but that's all right. It should be able to do that with a guaranteed performance, right?
Yeah, that's true.
And because if you put this out there and then those VLANs, they're dedicated VLANs, but they're not dedicated capacity, if they start getting stepped on, then they're going to say, well, what did this buy me, right? So when you do this, make sure you do it completely and make sure you do it well. And I would also suggest that the campuses, while they may not have as big a budget as the Trans-European Network does, they're pretty smart people too, right? And we shouldn't recommend things to them out of just trying to reduce the cost if it's not going to be a scalable proper solution for them.
Yes, I agree.
Right?
So this is why I'm looking at this kind of solution as demonstration, yeah, as demonstrative only, or the way how we can reach at the beginning some users in the campus network, yeah, because I think if we will start the process, then we will immediately start to talk with metro network with campus network admins, what are their needs and how probably we can implement this BOD natively in the network, yeah?
I have a suggestion. Maybe we can make a box where in each of the ports you get a different NREN. So, sorry, I just remembered my old work where you had IP in one and telephony in another one and TV in the third. So,
Surfnet with the share.
Triple flow?
Hi. I think it's very interesting tool in a toolbox, and there are of course a lot of various different tools which you can use for all kinds of purposes, but it's dangerous to look upon one kind of technology and impose that on users and ICT departments. But I think that in some cases ICT departments might be interested, and you can deliver this kind of tools to the ICT department rather than to the end users.
Yes, of course, that's also possible if because anyway, if you want to implement such thing in the campus network, you always have to talk with campus network admin. Yeah. So if you agree that you will deliver this as a separate box, it's fine. But you also can say, okay, we will do this together with network admin. And for instance, there is also possible solution here, where, for instance, this box will be owned by campus network. Yeah. And what campus network will do is will use this stack VLAN options, for instance, basically. So he will simply map the interface, physical interface on one access box and connect with transparent stacked VLAN and this Q&Q technology to RAN or Metro network. And thanks to that, if you map, for instance, this port to your BOD database, it automatically allows you to reach this guy here. Yeah? So that's idea.
I always liked the idea of starting with a problem or a use case, and then together with all kinds of different experts decide what tool may be the best solution to fit the problem.
And it's just development. I mean, you can already do that. I mean, I have a BOD pub in my office. I mean, endpoint. If you take on Nordinet, if you choose a VLAN 2017, it goes to my office, but without a guarantee. So it's not that hard. Anyway, you want to go through your slides or?
Yeah, okay. You can. But I'm always at the end. I think MDVPN and BOD can work together because basically, as I said, think about MDVPN as multi-domain transport service. You can use it in any way you want. I mean, if you want to you can also virtualize your BOD implementation, having different BOD domains having different scope. Yeah, I mean, you can have one domain which has only RAN limited scope. You can extend it or shrink it. It depends on your needs. Yeah, and thanks to flexibility of this MPLS-based solution, you can you can even provide a guarantee for the bandwidth, because if it's functionality available on MPLS boxes that if you're provisioning service, you can do the commission admission check and see if you requested 200 megs for particular point-to-point circuit, if it is available bandwidth on particular LSP. So this is the functionality which is available on the box. Yeah, so you don't have to implement that in software. It's already available as MDVPN implementation. Yeah, so you can just simply use it as transport network, create abstract topology which will reflect your needs and start to use it. And what I think about BOD, I mean, you have to actively promote the service in our users, and not only wait until they will put some request to our NOCs and request some transmission services. I think we have to, with this demo packs, go to the campus network and say, okay, please try to use it, and maybe you will find some use case for that. Maybe we have to adjust some your need, some parameters of the service to your need. But first, let's just show to the end users that such service is available. One of the example I had just a few weeks ago was a laboratory in chemistry department where some measurement equipment was measuring something. The problem was that it sent data somewhere to US. And the professor made this experiment, was almost praying that please do not disturb my IP network, because if the connection will be broken, my experiment will fail. Yeah, so they will just relying on normal IP traffic, which is not so maybe reliable as circuit connected created in BOD infrastructure. So that's one of the background.
But I think the next step is to try in a couple of demo cases, and I actually have some in mind. With DFN, if you're interested, or with Renater, and we have a couple of small users that would be interesting. Now, Jerry, do you have any question?
Last point there.
I mean, here.
Just being pedantic. Tunneling is not the problem, right? It's making sure that we have the performance, the performance engineering done at each of the ports, the traffic shaping and policing, right? Because if you don't have the proper engineering, they're not going to get the performance that they're
Yeah.
expecting, right?
Yeah.
And frankly, the tunneling, I mean, that doesn't add any problems to it as long as the tunneling is done in the hardware, right? You know, if it's MPLS, you can stack it till the cows come home.
Yes. But I mean, the tunneling I'm mentioned here is about putting this, I would say, external PE or CE box close to this end user. Yeah. With native support, I mean, the campus network infrastructure will be prepared to provide. Yeah. Yeah. That's true. Mm-hmm.
Victor Oliver from Janet had a question.
Thank you. First of all, I'd like to apologize because I was listening to this presentation not from the beginning, maybe I missed something. Has somebody mentioned that current implementation of bandwidth on demand service within Géant is based on MPLS?
Yes.
Yes, and the same for Janet. We've got not a production testbed, it's just a testbed, but also it works, it uses Ethernet over MPLS. It's the same about Janet Light Pass service. So I think it's quite natural way of getting rid of dealing with every single user circuit using this two-tier structure of labeling user traffic. So I just like to return to my first remark about double tagging. It's not something Janet specific. It's a common practice of wide area Ethernet services. Any Ethernet provider currently uses, and if you don't use a second label or second tag, if you don't use tunneling of user circuits, you can't provide all services possible which meter Ethernet forum defined. For example, you can't provide per port services, you can't provide per VLAN range services.
Yeah.
So generally, it's a common way of dealing with user circuits within a provider network. So it's about tunneling, about about reaching users using tunneling. Currently, Janet testbed has just one user. It's a big project Bonfire located at Edinburgh University. Mm-hmm. So we use the same. We use a sequence of MPLS or Q&Q tunnels within our regional networks and core to reach this user, and it's a static infrastructure, and all bandwidth on demand dynamic happens within just our testbed. So it's, I think, if I'm not mistaken, it's quite similar to the Tomasz approach. Thank you.
Yeah. That's something similar as Victor said, because I mean the technology is the same. It's Ethernet over MPLS, and related to tunneling, he's also right. If we using basically port-to-port lighter circuit connecting two ports, I mean, then we are transparently transmitting Ethernet traffic, so we are able to provide many Ethernet-defined services. So yeah, that's true.
But I think, as Peter said, it has to be seen as a tool within the toolbox, as for people who want to try when other more satisfying solutions. I mean, in the sense that all the way, for example, layer 2 circuits. Then because to have the service used, we need a footprint that looks more like the map that you've shown. That if I haven't shown the similar map for BOD, but it's not as good. But SurfNet is not yellow on my map.
Okay. Do you have any other questions? Okay, so thank you.